Good afternoon, and thank you for joining us on our call today. My name is Nico Smrekar from Transcat, and I'll be your moderator this afternoon. Our webinar topic is Simple Steps to Improve Your Maintenance Program, Proactive Maintenance for the Rest of Us. This topic is being presented by John Bernet from Fluke. I'm sorry, his last name is Bernet. John is a mechanical application and product specialist for Fluke. Using his 30-plus years of experience in maintenance and operation of nuclear power plants and machinery in other plants, John has worked with customers in all industries implementing reliability programs. He's a certified Category 2 vibration analyst with over 20 years of experience diagnosing machine faults and is a certified maintenance reliability professional, CMRP. John served in the U.S. Navy as an electrician for 12 years. We expect today's presentation to last roughly 30 minutes, and then we'll answer any questions that have been submitted. During any time of the presentation, you can send questions through the question box to the right in your webinar controls. I also want to mention this webinar is being recorded. Each of you will receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to John. Welcome, John.
Thanks, Nico. So welcome, everybody. So let's get started. And so what we're going to be talking today is proactive maintenance. You know, how do we make improvements? And a lot of the things we're going to be covering, many of you may have already heard about, and don't worry about that because some of the things that we'll be discussing are things to help existing programs get better. Some are how to restart failed programs, and some are to start programs all over again. But we're going to start off by talking kind of a broad picture. What are some of the benefits and what are some of the challenges, and how has it been hard to start up reliability programs? And then we're going to talk a little bit about what are some ways to help get a successful program up and going and sustainable and providing good results. And then we'll finish up with some solutions and give you some ideas on what are some things to think about, to look into, to help build your own program, and then a summary, and then, like Nico said, we'll have some questions at the end. So first of all, let's, again, many of you may have already heard of some of these terms, but for the past 30 years, there's been a lot of different terms bounced around. You've probably heard about reactive maintenance, run to failure, where there's a lot of unplanned downtime and a lot of lost production and hard schedules. And this is something that we've all strived to get away from. When I was in the Navy in the 80s, the way we moved away from that was we did calendar-based maintenance, PMs. And I was a PM coordinator in one of the engine rooms, and I spent all my time building these PM schedules, and that was our way to get away from run to failure, but it had some problems in itself in that quite often we'd take a perfectly healthy motor and we would overhaul it, and then it would break down. So it was better than running it till it failed, but sometimes we're making a lot of work. And then we heard a lot about in the 90s and then sense of some condition-based programs. And sometimes we've heard things like they'd be called predictive maintenance, which I personally, I'm not sure if I like that word because we really can't predict when a machine is going to fail. But we would use trending and technologies to find out what's going on. So now we're kind of backing off of some of these really given things terms, and we're talking more generally and calling things more of a proactive maintenance. So anything other than just running a machine until it's failed, let's call that proactive maintenance. So let's talk a little bit about what is it to be proactive. What are we striving for? Well, and most of you have heard of these benefits, and a lot of it, say, hey, it's the pot of gold at the end of the rainbow. We want to stop downtime. We want to make it safer so machines aren't blowing up. We want to increase the reliability so you don't have catastrophic failures. We want to build peace of mind. We don't want to have to be worried about, what machine is keeping you up late at night. We want to be able to have predictability. So a lot of different industries, a lot of different applications, a lot of different people are, looking at different parts and saying, this is what I really want. So it depends on your application, your need, whether predictability is important, whether revenue is important, whether reliability is important, or keeping the maintenance costs down. There's a lot of different reasons. So if we're all trying to improve our maintenance and have some of the benefits of proactive maintenance, what has been getting in our way? And a lot of it has been, the investment, having to build more resources, training up a team. But really, it's the culture shift. It's the company change. We've been doing things and run to failure for so many years that it's hard to be able to change that. It's hard to be able to, and sometimes what we found is it's only the most critical industries that have, that bite the bullet and pay for some of these really expensive reliability programs. So how can we overcome some of these problems, and how can the rest of us build programs? So that's what we're going to talk about is how can little companies or medium-sized companies do some things with limited resources. So let's talk about some of the more recent things, because a lot of you have heard about this or have had programs that have come and gone. But why are we talking about this again? Well, a little bit of it is the economics. Downtime is getting more and more expensive. Maintenance departments are having to do more with less. We have a workforce that's getting leaner. We have a lot of our specialists are retiring. So what are we to do? Things just seem to be getting worse and worse and worse and worse. Our budgets are getting smaller. Our goals are getting larger. Our production rates are getting faster. But what do we do? Well, the awareness is getting higher as well. You're seeing more and more maintenance practice journals and groups and trade shows. The good news is the technology is also getting better. So we're seeing the price of tools come down. We're seeing the complex tools become easier. And so more and more companies, not just the petrochemical companies or the power companies, we're starting to see manufacturing and facilities and other companies are starting to say that, hey, we need proactive maintenance to be able to make our company more competitive. So how do we do that? Well, let's talk a little bit about what I've learned over the past 30 years and what other maintenance professionals have learned is that there's really three things we need to think about that builds a successful maintenance program, and or the other way of looking at that, things that get in the way that cause us not to be able to be successful to start a maintenance program. And the first of those is a successful startup, and so we're going to talk a little bit about what does it take to start up a new program, because there are some. That's where a lot of programs fall flat. Is that they never get started up right. The next thing is what technology, what tools, what kind of things do I need? And so we'll talk a little bit about some of the new smart tools that we're seeing come on the market and how these tools can be used to help smaller companies and companies that don't have experts in-house to be able to start a program. And then last, what do I do with all the data? Because that's the third thing that causes a program to fail is if you don't have answers, if all you have is a bunch of numbers, then the program isn't going to make it. We have to find a way to start up a program, use tools that our people can use, and then get answers from that data. So let's talk about these things. So we're going to talk about the three pillars to start up a successful program. Now, as we start up a program, some things we want to think about is the first thing we need to do is we need to have a list of our machines. And we need to score those machines. And so this doesn't have to be something done with a very complicated program. You don't have to have spend weeks and weeks. I mean, this can be just a simple spreadsheet like you see down here at the bottom of the page. It could be just a matter of spending some time and grouping the machines based on what you classify it to be critical, either production limiting or what doesn't have backups, what's not vital. But first of all let's just make a simple list of which machines are critical, and then that can help us to make up a testing schedule. So of course we only have a limited amount of time, so I'm not going to dig real deep into this, but one of the first things we need to do is let's make a list and let's figure out what kind of machines are important and what do we need to monitor. Because as we get into this, and once we start making up our criticality list, we start to realize that everything is critical. And so then how do we decide what is important, what is critical, and what isn't? And there's four kind of ways of thought. One is you just make a list, and at a certain point you do a cutoff, and if it isn't critical, we don't talk about it. But that has problems in that there's a lot of machines that might not be critical, but if they fail, the rest of the plant goes down. The second is you just make a list that's prioritized. So in other words, if you've got 100 machines, you prioritize them by what's the most important, and then you just work down there until you run out of time. So if you've got time for 20 or 100, whatever you got time for. But the problem is again, that's not perfect. Another one is you could you just monitor everything, but just extend the schedules out. So if you had enough time, you could do everything. The problem we see with that is as time gets less and less and less, you're finding that you're just not getting to some machines. And the last one is full coverage. The idea would be, hey, everything is important, and I'm just going to have to hire a bunch of people. I'm just going to have to have a bunch of resources, and then you run into management's telling you, nope, you just don't have that kind of money. So all of these can be problems, and they're unsustainable. So let's try to dig into some other ways of attacking the assets in our plant. So another one way of doing this is, let's take a different approach of categorizing our machines, and maybe not just having a critical, non-critical list, because if you have a critical, non-critical list, then it's hard to decide which machines. What if all your machines are critical? So a better way to look at your machines may be to group them by which machines are your star athletes, the ones that even just a small change in performance is going to impact your bottom line. So those are really, really important production limiting machines. The next are our critical machines, and that's probably going to be the ones that we're going to focus on. But then, and with the critical machines, revenue equals uptime. So those are important, but not quite as important as the star athletes. And then you've got semi-critical and non-critical. So with semi-critical, even if it wasn't that critical, it could put a strain on production. And non-critical, probably don't have to worry about those machines. So if we use these types of grouping, and we dig in a little bit deeper into this, we still run into a problem, and that is, everything is critical, and other groups have found that same problem. If you look at the healthcare industry, what have they done over the past 30 years to address this? Because when you think about it, every patient is equally important, and you only have so many resources. So if you have limited resources, how do you handle everybody? Well, you can either, like we did earlier, find out which ones are critical and which ones aren't critical, but that's unacceptable, because you can't tell a patient you're not critical enough. The next thing is you could build up a lot of resources. Well, that's unsustainable, and there's no way you can do it. So how have medical professionals done that? They've used a tiered approach, and all of you are familiar with this, I'm sure. When we first go in to see a doctor, you first see a nurse or wellness screening. And if the nurse checks blood pressure, pulse, temperature, finds nothing wrong, or finds a simple thing that the nurse can fix, well, then we can fix it and be on our way and don't have to go see the doctor. Once we go see the doctor, then the doctor is going to be a little bit more specialized, but then the doctor is really focusing on, a general practice doctor is really focusing on some common problems. Colds and flus, cuts and bruises, broken bones, viruses, infections. There's really a finite number of things that they really cover, and that's going to cover 90% of what your problems are. And so the doctor can probably fix those problems, and you can be on your way and being all taken care of. There's only a small percentage of people that need to go see a cancer specialist or need to go see a heart surgeon or something like that. So the medical industry, as a way to handle all of the patients and give them all quality care, they found that if they have a tiered level of workers with a tiered level of training and tiered volumes of visits, then you can handle things in this tiered approach, and that way you can give care to everybody with based on what they need and based on the skill center. So that's what we're going to think about is there a way we can do this with our maintenance world that we can give this same level of care? So if you think about it in the maintenance world, if we were to break up our assets by non-critical, semi-critical, critical, and star athlete, then you could see with this tiered maintenance approach, similar to the tiered approach that the medical industry uses, we could screen for potential problems. And we would be using entry-level technicians with simple screening tools. And so if you've got 5,000 machines, let's not try to analyze all 5,000 machines. We don't have the resources for that. We don't have enough experts for that. Let's start with entry-level technicians using simple screening tools looking for potential problems. Once they find some potential problems, then we bump it up to the doctor, and the doctor would be, of our machines, would be a little bit more experienced technicians using diagnostic tools that would find the common faults, just like our general practice doctor, looking for root causes, looking for answers, and then they would probably be handling most of our critical machines. But you can see a lot fewer machines because we've screened out the assets that were healthy, and we've screened out the assets that could be fixed easily. So now the experienced technician with a diagnostic tool is going to be able to screen out and find the most common problems with the majority of our machines and only bump up a few to the analyst, to the expert, and the expert is going to spend most of their time with our star athletes, our really super critical machines. So what does this do for us? Well, the benefits of doing this tiered maintenance approach is we don't spend time analyzing healthy machines. We screen out the healthy machines because if 80% of your machines are healthy, let's not spend a lot of time on them. We also want to reduce the number of work orders and don't send out experts for simple problems. So start by screening with entry-level technicians, then diagnose the most common faults and save the important ones for the star athlete. So let's talk about what are some tricks. Now I don't have very much time, but one thing that we have found is start small and grow. Don't start with all 5,000 assets in your plant. If you do, the program will never get started before upper management says, hey, what's going on? Why haven't you got any results yet? So what I've found to be successful working with customers is start small and grow. Start with 20 or 30 machines show success, wave your flag all over the place, and so before they get a chance to say, what have you done, you've already got some results. You can then get more budget and grow the program. Start with simple machines. Don't start with the most complex machine in your plant. I know everybody wants to do that, but let's start with some simple machines. Let's show some success. Let's wave the flag, and instead, and don't fire your service provider. You know, you need to use your service provider, like we showed you in the earlier example. You can work on the simple machines and the diagnose in the standard machines. Let your service provider use their expertise on the high-end machines. Okay, so those are some ideas on how to start up a successful program. Start small and grow. Start with simple machines. Get some successes, and then get some budget and grow your. Start with baby steps. Get this thing up and going before somebody tries to axe it. The next step is what technology are we going to use for our program? So this curve is called the potential failure curve. There's a lot of different technologies, but what I want to point out here is that when a machine first starts to fail, we can use different types of technologies, vibration, electrical thermography, to try to find out our fault before a machine fails. If we let a machine go until it's noisy or it's hot to the touch, which is what a lot of people do, the problem is the damage is already done. The cost to repair has increased exponentially. The energy waste has increased exponentially. So what we want to be able to do is find some ways to trend our machines by screening, of course, and try to find these machines as they start to fail, not when they're just about to fail, because then the bearings are wiped out. The shaft is already wiped out. It's already too late. So how can we do that? Now, let's look at this tiered approach using tools, and I'm going to use vibration as an example. 30 years ago, all we had, for the past 30 years I should say, we've only had two tools, the high-end analyzer and the low-end vibration tool. The high-end analyzer was quite often too much because it needed an expert and it required a lot of analysis, and the low-end tool was too simple and it didn't give us any information. So let's think, so with technology, we've got some new tools that help us to be able to do a more tiered approach. We still need to have an expert's tool, and we still need to have simple tools, but we need to have something in the middle. We need to have something that allows us to screen to find out which machines are good or bad, and we need to have some doctors, like the vibration tester, that allows us to get answers without having to have an expert. So let's take a look at this. So if you look at the pyramid that we looked at earlier, and if you think about a pyramid where at the top of the pyramid are your very complex machines, in the middle of the pyramid are your mainstream machines. 90% of the machines in almost all plants are basic motors, pumps, fans, compressors, blowers, spindles, gearboxes, and belts. So why use a high-end analyzer and a vibration expert? And again, we're just using vibration as an example. The same thing can be done for electrical tools or for thermography tools. But if you were to look at your tools, why use a vibration analyzer on simple motors, pumps, fans, compressors? So the vibration tester is an easy-to-use tool, just like the doctor, and it's looking for our most common faults. I've been analyzing data for about 25 years now, and there are 4 faults that I see every day: imbalance, misalignment, bearings, and looseness. So the vibration tester has been designed, just like a doctor, to focus on the most common things that happen with all machines. Why focus on 4,000 different faults? We'll use an analyzer for that. And at the bottom of the pyramid, there's a lot of machines that we need to screen. That's where we're going to use a vibration meter to screen our tools. So this is a tiered approach to use some of your resources in your company to be able to start improving the maintenance on your machines without having to have a bunch of vibration experts or other experts on staff. So let's talk about how you would use these simple tools, because if you think about it, we don't want to just have one tool, and we don't want to have a whole, several of these really high-end tools. We probably want to have multiple of these simple-to-use tools. So let me explain what I mean by that. Because the first thing we need to do is we need to screen out the problems. So the first step is to use screening tools to find if a machine is good or bad. If it's good, leave it alone. If it's bad, bump it up and find out what the problem is. Then we would use simple diagnostic tools that would provide us answers, just like a doctor, and it's going to tell us what's wrong with the machine, what to do to fix it. It's not going to be able to be used on the very complex machines, but on your motors, pumps, fans, compressors, and blowers, those faults are pretty basic. Once we find out what the fault is and what to do to fix it, let's use some easy-to-use laser alignment tool, for example, to correct the problem. You don't have to be an expert to be able to use this tool. So using these simple technician that can be trained up types of tools, we can screen our machines, we can then diagnose our machines, we can then correct the few machines that have problems, but then finally check our machines with the same tools, because before we put that machine back in service, we need to make sure it's working correctly. Okay, and the last step is, what do I do with all of this data? And there's extremes. If you look down at the bottom, you can see that we can use a clipboard, or we can use a high-end CMMS system. And then our assets, we have simple motors and pumps, and then we have high-end turbines and generators and complex blowers, So let's think about the different assets and the different tools we have, Where do we start? Because we've got a bunch of data coming in. Now that we're using these simple tools to find answers, what do we do with all of this data? What is good? What is bad? It's like needles in a haystack, I need to get answers out of this information. And having more data isn't always good. You just get a bigger and bigger haystack. So if we have more data, is it going to help this guy down here at the bottom of this haystack find a needle? Probably not. So we need to find a way to get information out of that data. So I'm not going to go through this because we're running a little bit low on time, but we'll give you copies of this presentation. But when you think about it, what do you do with data? The first thing is it good data? Does it have good content? Do we believe its integrity? Using some of these smart tools, we can download that data instead of writing it on a clipboard, or and then also, how do we share that data? And then lastly, is it secure? Are we afraid we're going to lose that? So we can use some simple methods to be able to, and that can be from simple spreadsheets to high-end software, but we need to make sure our data has good content, has good integrity, is being shared amongst your whole group. So let's talk about some solutions. So one thing to think about is smart tools allow us to track all of the things going on in our plant. So if you think about it, there's a chain from left to right, the input power to your drives and your drive signals, to your windings, to your motor windings, to your pumps, to your fans, to your mechanical rotation. Anywhere along there from left to right, this process can be broken down, and if it does, production stops. So if we break this down into some basic tools to give you some ideas of some of these solutions, for electrical, we would be using some input power devices. We would be looking for scopes. We'd use some motor winding tools and motor insulation tools. So these are the types of tools that we would use that are electrical tools that would allow us to look for problems and troubleshoot problems in the electrical part over on the left. Then there's some tools that are thermography tools, thermal imagers, and some of these types of tools can be used both in the electrical components, the drives and the drive input. It can also be used in the motors. It can also be used on the mechanical side. So, and then finally, mechanical. Vibration that we've talked about, laser alignment that we've talked about. So instead of having just one tool, the electrician has one tool, the mechanic has one tool, some of these smaller, smarter tools are able to give us answers. And again, we talked about screening, diagnosing. Then let's share this information. You've got a bunch of different assets. You've got a bunch of different tools and a bunch of different team members. Instead of having a bunch of silos of information, we need to share this information in a tiered maintenance approach, because we have some operators that are screening our tools. We are screening using some tools. We have technicians using other tools on different assets, and we need to bring this all together. We need to have better, if we have better tools, smart tools, then we can have better work practices, better collaboration, and this can help us to build a proactive maintenance program to have a better culture. Okay, and the last thing, again, there's a lot of information here. I just want to kind of show you the way that we can kind of break up some of the faults that we're looking for. We can break it up by thermography, mechanical, electrical, and process. And you can look down here using imagers, looking for electrical, mechanical, and process. Vibration is looking for mechanical faults with rotating machinery. Scopes and power quality are looking to troubleshoot drives and drive distribution. Motor testers and insulation testers are using for problems in motors, and then process tools are used to troubleshoot or calibrate transmitters, valves, and those kind of devices. Okay, so as a summary, what we've talked about today, we talked about how to, the problems there are that get in the way of a successful program. And Fluke and Transcat can help you be able to start up successful programs. And we gave you some hints. Start small and grow, get some success, wave the flag, then get budget. So there's some things that we can do to help you to be able to start up a program. There's also some tools that we can help you with. A lot of the tools that we have available are smart tools. What I mean by that is they're going to help you in a tiered approach, screen, diagnose, and correct. And these tools are designed for technicians with minimal training to be able to go out and get answers, not have to have experts come out on simple machines or simple assets. And then finally, how to share that data and get that information out to the right people. Okay, so I'm all done. I've gone through this presentation and taken a little bit more than 30 minutes, but let's see if we have any questions.
Hi, this is Nico, and thank you, John. That concludes, obviously, our presentation portion. Just as a reminder, if anybody would like to ask a question, please send it through the question box in your webinar controls. We've got a few already. The first one was, will you share this presentation? Yes, we will. I have uploaded it to the webinar. I'm not entirely sure how to download it from there, but if nothing else, we will append it to the email that we send out, or at least to a link to it. It's a pretty large presentation, so us emailing out will probably not be the best option, but we will certainly post a link to where this presentation can be downloaded, as well as a link to the recorded version of the webinar. We've got another question here, John. Is the MET Temp 2 compatible with non-Fluke products?
Sorry, what was that question?
Oh, what was that? No, I'm sorry.
Oh, Fluke Connect.
Yes.
Is it competitive with other products?
Compatible with any of these products?
Yeah, yes and no. And so because I'm not I mean, the goal is to obviously, yes, have all of the Fluke tools. Right now we have about 40 Fluke tools that are on Fluke Connect, and every month we're adding more tools. And our goal is, yes, to have other tools be able to work with Fluke Connect. Part of the problem of, and I've been involved in the industry for many years, and the problem with integrating one vendor's solutions and results to another vendor's solutions and results is sometimes, having the vendors be able to, they don't always want to share that a common link between the two. So as of right now, I think the answer is no, but we are working on that. And so part of this is if we simply need to find a way to do that, and the internet has always been a really good way of doing that. For years and years, we've tried to integrate results from different programs, and then we find out that, hey, look at this, the internet does it for us automatically. So I think the answer is we're getting there. I don't think we're quite satisfied with a complete integration yet, but that we will be integrating it more and more. So I know that's not really the exact answer, but we're working on it.
Okay, that's good to know. Another question that came in was, is a certificate or vibration specialist certificate necessary for doing this work?
No. Well, so if you think about it, years ago, it took years of training to become a vibration analyst, and you would the path was pretty much you would go work for years to become a level 1, be certified, and then you could go out and take the measurements, and then you'd work another year and you'd pass certification for level 2. So to use one of the high-end analyzers, you probably are going to have to go through training and certification. But to use the screening tools and to use the diagnostic tools, no, you don't need certification. These tools are easy enough to use. For example, the screening tools, vibration and thermography and electrical, those tools can all be used by an operator or a entry-level technician with probably, I'd say, less than an hour's worth of training. Just have a technician, experienced technician, show them how to use it. The diagnostic tools, again, you don't have to be a vibration expert, and these tools have been designed so that a technician with minimal training can use these tools, because you're not having to, analyze, and look at a lot of analysis, because over the years, these tools have built-in auto diagnostics built into them, where on most of your simple machines, it's analyzed for you, and so all you're doing is setting up the machine and collecting the data, which is really easy, and then reviewing the results. And so the training, you're looking at half a day worth of training, and without a certification, and you're able to use these screening tools, these diagnostic tools, to get machine condition answers for most of the faults with rotating machines. So no, you don't have to be certified. Certification is only for the high-end analyst on those really complex machines.
All right. One more question. What is the best way to start or restart, in that case, a new or a failed proactive maintenance program?
That's a good question. So to start a program or to restart a program, we've kind of talked a little bit about that, but you know, some of the things that we talked about, you know, is, you know, start small and grow. Another thing is to start simple and not your complex machine, but you know, just go through the steps of how to start up a program. Is you would, you know, again, start with just a few machines and start with the simple machines, and you would just make a simple spreadsheet or a list. You first need to make a criticality list of what's critical, and don't start with the, again, the most complicated machine, and you know, something kind of in the middle, and start with a group of machines. And don't worry that your list of machines, your equipment list, isn't going to be perfect at the beginning. This is a work in progress. So don't say, hey, I can't start my program, or I can't restart my program until I have all my machines set up, and until I have my resources, until I have a plan, because if you do, it'll never get started, it'll never get restarted. The easiest way to do this is just start on a small group of machines, start with some simple screening tools, start finding out which machines are good, which machines are bad, and then start getting some success, and people are starting to say, hey, look, you're starting to tell me which machines are good or bad, and that way I know which machines to shut down so I don't have production losses. And then once you get that kind of, you know, started, then start moving into some diagnostic tools. And so start simple, start with screening tools, then work your way up to more complex, and work your way up to diagnostic tools. So kind of baby steps, a little bit at a time.
Awesome. John, thank you very much for the presentation. Thank you, everybody who attended. Again, we will share the presentation document and the video, the link to the video in a few days. And this concludes our webinar for today. Have a great day, everybody. Thank you again for joining Transcat and Fluke for this presentation on preventative maintenance.
All right. Bye-bye.
Bye-bye.